Dear everyone, in Lightnovo, skin measurements by Raman Spectroscopy was always our big interest. We took a lot of attention to it, and through last year we invested a lot to make it more user-friendly, more precise, higher resolution, more sensitivity with our devices. It went through the development of new hardware solutions, accessories to the body, to the core of the technology, like a variable skin probe where you can tune the penetration depth, as well as software solutions. Let's say we developed a special screen solution where you can monitor water content, lipid content, just instantly when you touch the skin, and quite a lot of on PC side. And James will guide us through the innovations and opportunities.
Yeah. Thank you very much, Alexei. So what we're going to discuss are the different configurations that we obviously offer. We're going to start off with our two 830 nanometer solutions. So we have the miniRaman Pro and the RGS, both of which have the options for an 830 nanometer laser. We're then going to talk about our Confocal miniRaman Pro, which would be in a 785 nanometer laser. And finally, we will go back to the old true tried and tested miniRaman standard, this one with a 660 nanometer laser. As Alexei was saying, that one we can do a bit more with looking at the water content, hydration of skin. So,
of course, as a general trend, 830 provide less fluorescence in average, and it's more suitable for more pigmented skin. However, spectral range is a little bit limited, so we start from, let's say, 100 inverse centimeters to 2500. But when it comes to 785, very popular wavelengths of the laser, you can also see CH with our device, so until let's say also from 100 to 3200 inverse centimeters. A little bit higher sensitivity due to the wavelengths, but a little bit more fluorescence in average compared to 830. And then 660 may not be the best optimal frequency or wavelength, many use cases in skin applications. However, the range is very attractive. So it starts from 300, but it ends at 4000 inverse centimeters. So you can see CH and OH band and quantify water amount and also lipids amount, let's say. We will show it to you later.
Perfect, thank you very much. So what I'm going to do is I'm just simply going to use my finger for these tests. So we're going to analyze the skin on the tip of my finger. We're going to try and use very similar settings between the two so that we're getting a real comparison of what the results are. This is the variable probe currently is set to 0, so it's focused very, very tight. We've got a very good numerical aperture here, so the laser safety distance is about 13 centimeters from the end of the probe, so you are perfectly safe. Definitely those through screen, but anyone else in the office, the lab, even us standing right next to the devices are perfectly eye safe, which is why we don't need to be wearing laser goggles.
On my side, yes, a little bit on that. So when there is no probe on device, beam is parallel, and that is class 3B where you need safety glasses and you are not allowed to point on other people and on your eyes. But when you attach the probe to the device like that, this probe and another probe, skin probe that we have two skin probes. One is fixed penetration depth, another is variable penetration depth. You just tune the treat here, and you can go from 0 to 300 microns in depth of the skin. But both of these probes have the same numerical aperture of 0.65, which means that beam divergence is huge, and laser power density drops fast versus distance. That's why after approximately 13 centimeters, of course depends on the maximum power you apply on the device, it's more or less safe for surrounding people and for yourself.
So I'm going to use this miniRaman Pro 785 system, and because we're looking at the confocality, I'm going to use a thinner region of my skin so that we can actually see some real differences as we go deeper into the skin. So using the variable probe, I've set it to 0 microns. I'm just going to...
Let me support you with
Thank you very much.
So I turn on the laser.
Yes, please.
And
yeah, we'll have the exposure set to 5 seconds. It will be clear later on why we've done that. Oh, I shifted a position and managed to saturate the detector.
It's okay, keep it there. So we may go to smaller. Yeah, you see 5 seconds is definitely too much, so maybe 3 seconds. Yeah, that sounds reasonable. And I keep 1 repetition and press capture. And this is gonna be, we call the spectrum 0 micron penetration depth. Okay, then please move to 100 maybe.
Yeah, so I have moved to 100.
Mm-hmm. We see signal is less intense, and I would press capture again. And after it's quiet, I will call it here. 100 micron. Okay, 200.
Yeah.
Okay, we see signal is decaying again. Yeah. Okay, and I press capture again, but I may use a little bit, like 3 repetitions, so we accommodate a bit on noise.
Yeah, I think that sounds reasonable.
Okay, and I call it 200. And the final is 300. Yes?
Yep, and we're set up at 300.
Okay, so signal is really weak, so I'm gonna cheat a bit and maybe put here 5 seconds.
Yeah.
And still 3 repetitions, and we press capture. Just to see it a little bit better at the end. So, you see repetition number 1. When it's gray, it's still processing. Number 2, and when it changes the color, it's complete. Okay, so I turn off the laser, and I would call it 300 micron penetration depth. Good. Let's analyze what we got here. And on a first look, let's say if we zoom a little bit this particular area, James had a very strong peak here.
Yep.
To be honest, I have a little bit of a challenge to comment what was that on a surface specifically, but I have a guess, maybe lipids rich surface of your skin.
Potentially, yeah.
Potentially, yes. And then it decays at 100 micron. And then here, at 200 you see it less, and then it disappears at 300 micron.
Yeah, so we're seeing a clear change as we go through the different layers of my skin.
Yes, yes. So that's the power of confocality. You can see the, let's say, cream penetration or drugs penetration through the skin, through the depths. And another indicator how deep you are, commonly appreciated in scientific community, is that when you go through epidermis to derma, in epidermis you have more protein, cell density is higher, so the protein content is higher there. And usually people discuss this area, that it becomes intensity in this shoulder less compared to the surface when you go deeper. So you see this peak was pronounced at the surface, and when we go deeper it becomes less. So when you are flat, it's like in between your epidermis and derma, and when this peak is a bit less compared to this part, you are most likely in derma already. So that's another indication of penetration through the skin layers.
Yeah. So yeah, so there's a lot that you can explore within the different layers of the skin by using our confocal system with this variable probe. You can, of course, do it a bit more manually with one of these, or you can buy multiple of these so that they're set at configured distances to, depending on the workflow that you have in store. So the last part that we're going to move on to is going to move away from the screen, or at least from this big screen and our MiraSpec Flow software, and it's going to be an actual onboard chemometrics that we've put onto the miniRaman to specifically look at things like the lipids and the water that you see in skin. And so for that, we need to have a 660 nanometer wavelength, so we have that extended range so that we can actually see the peaks that are of relevance. Does mean that we lose the information from all of the fingerprint region, because the fluorescence is so large that even with my skin, which is not very fluorescent at all, you still have a lot of problems seeing that fingerprint information. So I don't know if you want to...
Yeah, we can do that. I can comment and you can do some measurements.
Yep.
And before we jump to this particular measurement, I want to make a general comment on laser power, not for safety, but for the skin measurements and safety of your skin. So here we used multi-mode lasers, and maybe you remember we settled power on a device around 350 milliwatts, and on a sample it was maybe around 250 milliwatts. However, it's a multi-mode laser that provides a line on the skin instead of a dot. So you spread the power density to a large extent. So with this probe, your sample volume was approximately, line size was approximately 50 micron. And then it's as narrow as around 10 micron. But this one, where we demonstrated confocality, it was a single mode laser, and the power, you don't need as much to reach as good signal. You saw signal was at this laser also very good, but here power is set to 63 milliwatt, but it's without the probe. After this probe, you will get maybe approximately 40 milliwatt on a sample. And that's already quite gentle power level. If you want to collect twice longer, you can go to 20 milliwatt and enjoy your measurements in a fully safe for skin conditions according to the regulations. This is a device also confocal, single mode, but 660, and power level is also approximately 30-40 milliwatt, and you can change it twice, 3 times less if you want.
Excellent. So let me come out to you so that you can come and see the screen. So if you can see, what you can see right now is I am saturating the detector, but you see that that saturation is slowly disappearing as my skin is being what's called photo-bleached. So essentially the fluorescence is stopping. As I'm shifting, you can see just by simply shifting my hand a little bit, I'm changing the signal a lot. But we have these 4 metrics out here. So we have water content at the beginning. Alexei?
Yes, the water content here you see 30%. And we will show in other areas of James' arm it may differ for the relevant reasons. Then we have some other ratios like the protein, the lipid ratio here, yes, and then asymmetric to symmetric peak ratio and some other parameters. But water content and lipid content are the most interesting. Let's monitor the water in particular. Now it's around 28 in this area. Try maybe somewhere here. Stratum corneum depth is at this area is less, and you should get closer to derma, maybe at this penetration depth, and you see it's already 61% of the water content. So peak of water is higher in this area, and on a finger it should be lower again if you try it like that. Yeah, you see it sinks it almost 0. Maybe too much fluorescence shift a little bit the point, but yeah, you see it's 26, 27, so it's quite low as well. Yeah, and just to demonstrate it again on me, let's say here.
Yep.
Try it. You see 66, I have 64 here. And one more time my finger, 511. So method really works. And the lipid ratio and water content, those are two very important parameters that directly impact skin wells. So basically, the more lipids you have, the more water you have, the better, but there are naturally different parts of the body that have different percentage.
Yeah. Excellent. So I think that what we've been able to show is that Lightnovo has a wide range of devices and for different applications, from looking at the hydration in the skin to looking at specific layers to even just bulk measurements, so that you're able to just see broad differences between different skin samples.
Very important, I mentioned that all of this is a sum of innovations in hardware, how to be sensitive, high resolution, how to control the penetration depth with accessories, how to quantify water lipids with software inbuilt in the screen. So these software features you can upload in all of the family of our devices and have certain parameters. However, the most advanced stuff that will give you not just a Raman spectrum but a result you can do on this software on PC. We have here option to do the different type of measurements. So if I close it and I try to create a new project, let's say skin something, and I can select classification and classification type of analysis. So basically you can measure different classes of skin, diseased, healthy, and then it can be any. It can be cancer-based, it can be atopic dermatitis-based, and then you can build a model with big amount of data on this software and upload it on the device, similar as we uploaded a water quantification model. If you want to quantify something, you can select another analysis type. Instead of classification, calibration, yes, and calibration here. So it will then show you content like water, but whatever parameter you build model in the PC through the database that you develop on multiple patients or multiple standard materials you use for your research. So possibilities are very broad. You can do extensive research with the computer, you can build the model, you can collaborate with us to build the model, upload it on device, and just see the results on the screen. And by the way, mobile application exists as well, so you can see results on mobile, transfer them on cloud, and never lose your data, even when you are not in your laboratory.
Yeah, so that's really all we have to say about the skin application and the hardware developments here at Lightnovo. Thank you very much for watching. Thank you very much for working with me on this, Alexei.
Thank you, James.
And yeah, it's a pleasure to be part of the videos.
We look forward to your reply to us, contact us, text us, call us. Thank you.